Hello friends, welcome to SahuStudies. In this video, I am going to discuss difference between reduce by key and group by key in Scala. So let's discuss about reduce by key first. Before starting, this video is more related to the differences, theoretical differences between reduce by key and group by key. I have created a separate video for the practical implementation of reduce by key and group by key in Scala. If you want to get to know, or if you want to understand how reduce by key and group by key can be implemented with Scala, go and watch those videos. So let's discuss here the differences between reduce by key and group by key. Let's discuss about what is reduce by key. So reduce by key is a transformation function. It is a transformation function, or we can say it is a wider transformation function. So whenever you are going to perform any kind of a transformation on a RDD, we can use reduce by key function. It is a wider transformation. That means data will be shuffled across executors. But the good part in reduce by key is that shuffling of data takes place at the last stage of transformation. It is used to merge the value of each key. It uses associative reduction function on the PySpark RDD to merge the value of each key. What does it mean? It means that it going to merge the value of each key with the help of an associative reduction function. So, for instance, suppose in a RDD there are 10 different keys are present, and the number of records may be 1000, but unique key is 10 only. So what group by key will going to do? It will merge all the value of the same key with the help of a associative reduction function. So it is a wider transformation, hence shuffle of the data occurs into different partitions. So as I told you that if transformation is a wider transformation, then the shuffling of the data across different partitions will occur. Hence, since reduce by key is a wider transformation, the shuffling of the data may be occur across different partitions. It operates on the pair RDD key and value. So this is very important, right? Reduce by key always work on the pair RDD where the data is stored in key and value pair. It is very useful when there is a requirement to perform aggregate function on the value which are associated with the key. So let's understand this point. So what it will going to happen whenever we are going to merge the data, merge the value of the same key, it would be very helpful if there is a requirement to do any kind of aggregation function like sum, count, mean and max. So if you want to do certain kind of aggregation function on the values per key, then reduce by key will play a very important role. One of the main advantage of reduce by key is that it reduces the amount of data that need to be shuffled and stored in the memory. So whenever we are doing any kind of transformation in Spark, so most of the time, if the memory is available, data is stored in memory only, and all the aggregation function happen in the memory only, right? So what is the good part of the reduce by key? The good part of the reduce by key, it reduces the amount of the data by applying the associative reduction function in each partition, or we can say in each key, due to which data become very small and it easily stored in the memory. And when the shuffle operation will happen at the last stage, very little amount of data will going to going to be shuffled across different partition. That makes reduce by key very performance optimized function. One of the main disadvantage of reduce by key is that it requires the reduce function that is associative and cumulative, which may not be in the case of all the aggregate function. So suppose till now what we have understand that if you want to do any kind of aggregation function over the all the values of the key, reduce by key will going to play a very important role by achieving that thing with the help of associative and cumulative way. But if you talk about the all as aggregate function, this not be the case. For instance, suppose you want to take median, if you want to take mean, those are not the associative or cumulative transformation or aggregation. So at that place, this reduce by key will not going to perform better. So let's discuss how the reduce by key will going to reduce the value in a pictorial representation. So suppose this is one of the partition or which is present in a executor. Here the value, there's the one value of A and the one value of B. So in the same partition, it reduces, and here the since there is only one value for each key, so this is the output. And it is, so one thing is very important, it is happening in the same partition. This is the second partition. So two value of A and two value of B are present. So when it reduces, so it is become like one for A and one for B. And what is the value? So suppose here we are doing the sum aggregation, right? So the value is 2 because one is from here, 1 1 and 2. For B, 1 and 1 value is 1 1 1 for both the records. That's why the value is 2 only. So here suppose this is the third partition which sits in the different executor. So here there are three values of A. It reduces like this. A is the key and 3 is the total value. B, there are 3 records for B keys. It reduces to 1, right? This is the B as a key and the value is 3. 1 from each value from here. So we have seen here that the reduction function is happening first at the same partition. Now, when all the reduction function happen, all the reduction function completed, then what at the last stage, what reduce by key is doing, it shuffles the data from different executor to another executor in a partition. So suppose this is the partition which sits in a different executor. So all the values from this partition, and this partition, they are coming here. So this value A1, it is coming from this partition, this one from this one. A2 is coming from the resultant of reduction function which has happened in this partition, that is this one. And A3 is the result of the reduction operation which has happened in this partition. So all the values which are associated with key A now shuffles in this executor or in this partition. Same for B. This record is coming from the resultant of reduction function from this partition. This B2 is the result of the reduction function which has happened in this partition, and this is the B3. The B3 is the resultant of the reduction which has happened in this partition. So we can see now there are two partitions are available here based on the each key. And one is the more important thing, like I am just talking about again and this again and again, that the shuffling is happening at the last stage of the transformation. So suppose this is a very small data set. So for the visualization purpose, I am just taking this example. This is a very small data set, but suppose in this partition, in this partition, in this partition, if the data sets are very huge, so it is doing a reduce of operation internally. So data is reducing from 1000. Suppose in this partition for the value for the key A. So suppose there are 1000 records may if suppose it's present. So it's going to reduce only one value. So the reduction of data is also taking place. So suppose here if 1000 records are there and the data is supposed for 10 MB, but when the reduction operation applied and this data is reduces and it's getting the sum with the each key could be data reduced to 1 MB also. So from 10 MB data is reducing to 1 MB, 1 MB. It is a huge thing. And when the data is shuffling from different executors, now the data is very small. So the shuffling of the data, it will be very fast because whenever the shuffling will going to happen, the data will be stored in the memory. Since the data is very small, it's stored in the memory, and the shuffling transfer of the data from one partition to another partition will become very fast. So this is the one of the major advantage. That's why in the most of the time we prefer reduce by key over group by key. Let's talk about the group by key, right? Group by key is also transformation function, and it is a wider transformation. So whenever we want to do any kind of a transformation, we can use group by key function. It is a wider transformation, means the data will be shuffle across different executor. So it is used to perform aggregation such as count, sum, mean, max, etc. It suffers the data across different executor when the data is not partitioned on the key. So this is very obvious. If the data is not partitioned and we want to do a group by key, so what the group by key will going to do? It will combine the values of the same key. If during this grouping of the same key, the data will suffer from different executors. That's why it is saying that it requires a lot of shuffles operation in group by key. It takes key value pair as a data input, group the value based on the key, and the return the pair identity. So this is very important that group by key always take place over pair identity, or we can say the data which is present in the key and value pair, it groups the value based on the each key and returns a pair identity. It is very costly operation as it consumes a lot of memory if the data is big. As I told you that it is a wider transformation, so it requires a lot of transformation or a lot of data shuffling. And the data shuffling, it starts from the very initial stage of the transformation. So if the data is very big and if the data is shuffles across different executors, so it requires a lot of memory that makes the group by key not a very good optimized aggregation function. It performs better whenever you want to do group the data based on the key, but do not want to perform any aggregation function on the value. So there is a one scenario where group by key will perform better, and the scenario is if you want to group the data only, but we don't want to do any kind of aggregation function. In that case, group by key will be better than the reduce by key. One of the main advantage of the group by key that it is very simple operation and does not require any complex logic. So the code is very simple. On the RDD, we have to just call this group by key. So the operation wise and for the coding wise, it is very simple. And we don't require any complex logic to group the key or merge the value of each key. So it is very simple. It does not require any complex logic. One of the main disadvantage of group by key is that it is inefficient with the huge data set because it suffers a lot across network and stored in the memory. As I mentioned that this is the one of the disadvantage because when the data set is more and the shuffling of the data started from the very first stage of the transformation, and if the data set is very huge, those data would be stored in the memory, and when the shuffles happen across different network, that will make the performance slow. That's why most of the time, if we need any kind of aggregation function, then it is advisable not to use group by key. If the data set is huge, instead use reduce by key if you want to do any kind of a transformation per key lead. Let's understand the group by key with the help of this pictorial representation. So this is the partition which sits in one executor. This is the second partition and this is the third partition. So suppose we going to apply the group by key on the RDD. So at the very first stage the shuffling is happening. So this record is coming from here. These two records are coming from here, and these are the records which are coming from here. Same as B, this record is this B is this B is coming from here. These two B's are coming from here, and these three B's are coming from here. So at the very first stage, the shuffling has happened. So when the data will shuffle from the first stage, the data would be very huge. Then it required a lot of memory to store and makes the group by key not a very performance optimized aggregation function. And you can see here the aggregation is happening at the very last stage when the data is shuffled across different partition and the same key comes in a single part in one part in each partition. So this is the A which now become a partition in and stored in this executor. This is the B which is a part of this partition which is storing in the different executor, and when it shuffles then the aggregation is happening. That's why it's make very not very much performance optimized group optimized aggregation function. So you can understand. So I think you can able to understand that why this is not a very performance optimized because it requires a lot of memory during the shuffling operation. So let's discuss about what is the difference then. Okay, so some of the differences we have able to figure it out since we have discussed a lot. What is the reduce by key? What is the group by key? We have also seen how the reduce by key and group by key functions in with the help of a pictorial representation. But still, let's discuss what is the differences again. Okay, so let's talk about the reduce by key. Reduce by key is more suitable for cumulative and associative reduction operation on the value. So whenever you want to do min, max, sum, count, so this reduce by key plays a very important role and it is a very performance optimized. It performs the logical operation on the each partition before shuffling. So this is very important, right? So first it do the logical operation in the partition and then shuffles. That's make the reduction of the data, and when the data will become very less, when the shuffle operation going to perform at the last stage of the shuffling, it is very fast. That's why it is very much performance optimized. It requires less memory. As I mentioned that the data reduction has happened on the partition label before the shuffling. That's why it requires less memory to store the data which will going to shuffle across different executor. It has a limited flexibility because it has a fixed reduction function. So one of the disadvantages of reduce by key is that it provides limited flexibility. You cannot write a custom reduction function because the reduction function is fixed. provide better performance due to the logical aggregation, which I have just mentioned again that it provides the logical aggregation at the each partition level, and then it suffers the data, which makes it which makes reduced by key performance optimized aggregation function. So let's discuss about the group by key. It groups all the value which are associated with each key into a iterable collection. We have discussed, right, that group by key, it will going to group the data based on the key, and all the values are present in the iterable collection. And if you want to do any kind of aggregation, then on the iterable collection we can able to perform it. That is the addition or finding out max, mean, what is the mean, what is the count. It shuffles the data across executor. It leads to more data movement. As I told you that the aggregation is happening when the grouping of the data happen, and in between the grouping of the data, there's a lot of data movement happen in the different executor across the network. And if the more data will be there, we are going to consume more memory, and it will lead to more data movement because the data is more before aggregation. All the values are stored in the memory. That's why the large data set, it could be memory intensive operation. So if the data is more, Spark is do all the transformation in the memory. If the data is more, if want to store all those data into the memory, that will become a very computational intensive operation. It provides limited flexibility in the custom aggregation function. So same as reduced by keys, it's also not going to provide more flexibility whenever we are writing the custom aggregation function. For the large data set, the performance would be very poor. As I told you, for the large data set, the shuffling of the data will going to happen at the very initial stage. The data movement across the network is huge, and the data will stored in the memory. That makes the group by key not a optimized aggregation function. So in this video, we have discussed the difference between reduced by key and the group by key. We have seen advantage and disadvantage of reduced by key. We have also seen what is the advantage and disadvantage of reduced by key. We have also seen how reduced by key functions with the help of a pictorial representation. We have also seen how group by key functions with the help of a pictorial representation. And the conclusion is that avoid group by key whenever we are doing any kind of a transformation over the aggregated value of each key. Prefer reduce by key if you want to do any kind of aggregation over the aggregated value of the aggregated value per keys. I'm talking about aggregated value per key. Let's thank you. If you like content of my video, then please subscribe my channel, like it, comment on it, and press the bell icon to get notification whenever I add videos.